नोड बोलते हैं। एंड देन जितने भी बाकी जो भी हमारे नीचे के क्लास होते हैं इसे बोलते हैं हम लीफ नोड। ये बेसिकली हमें एक प्रेडिक्शन वैल्यू दे रहे हैं, तो इसे बोलते हैं हम रूट नोड, और इसे डिसीजन नोड भी बोल सकते हैं क्योंकि यहाँ पे एक डिसीजन लिया जा रहा है, जैसे कि डज हाउस हैव मोर देन 2 बेडरूम्स और नॉट। यहाँ पे अगर यस होगा तो देन यहाँ पे हम लीफ नोड पे जाएगी एंड देन इट विल प्रिडिक्ट द हाउस हाउस प्राइस की वैल्यू जो वो प्रेडिक्ट कर देगा। अगर नो होगा तो देन जो भी हमारे डाटा सेट में प्रेजेंट है उस हिसाब से वो ये प्रेडिक्ट कर देगा। सो डिसीजन ट्री आई गेस बेसिकली ज़्यादा कुछ हार्ड नहीं है, बहुत इजी है। सो नेक्स्ट एक यहाँ पे हम डिसीजन ट्री को इम्प्रूव कैसे कर सकते हैं। ओके, वेट अ मिनट। सो ये कोर्स आई गेस ब्रायन ले रहा है एंड देन आई विल टेक द सेकंड कोर्स, क्योंकि मैंने भी वो सेकंड कोर्स अभी पूरा कंप्लीट नहीं किया है, तो अच्छा होगा अगर साथ में कंप्लीट करेंगे तो फर्स्ट कोर्स ब्रायन लेगा।
Thank you, Saurabh. So, yes, Saurabh, वो screen share जरा.
ओके ओके।
Yeah, thank you so much. Just a second, guys. I'll share my screen right now. So yes, is my screen visible? Guys, screen visible. Okay, yes, thank you so much. So guys, the links that I've shared on the group, when you click that, this is the first thing that will open up here, and I've completed this course. So lessons, yeah, I think kitne, 7 lessons are there, and you go to your first lesson, click on that, and here you will get a short introduction on how machine learning works, what is the different things that you do on it, a small introduction, and this is a machine learning algorithm called decision trees. You can read on this, of course, later, and then we have your improving decision tree. How do we improve it and all? So all this is theory. You can read it later, no problem. We'll directly start the solving part, the coding part, so it'll be easier for you all. So we'll go with basic data exploration, that is start tutorial right here in the bottom right corner, if you all can see. Yeah. So here we are reading something called use pandas to get familiar with your data. Pandas is a library used in machine learning, especially it's in Python. So we use it in machine learning to manipulate our data, numbers and all. We use this to read our Excel files or CSV files into data frames. So here again, there is a lot of theory given, and this is a sample code given. When you write this code, you get this kind of output, which is this output that you get right here is called a data frame with rows and columns. Okay, so all these rows and columns are called data frames. And here, so let me just give you a short explanation on what this is. So to access our CSV file, now I hope you all know that the datasets are usually stored in CSV files. So to access your CSV files, you need to give a path. So inside input folder, we have Melbourne housing snapshot. In that, we have the melb data.csv file, which is a data set. Okay. So we store this file path in a variable and we read this variable using pd.readcsv. Okay. So this is a function that we have right here. So you all must be confused that what is this pd? Let me just tell you what it is. If you'll come here on top, see we have imported pandas as pd. Now we write pd is because it's called an alias. Okay, this is another keyword. It's called an alias. Pandas is the word. Pandas is the name of the library, but we are importing pandas as pd. So next time, whenever we are using this library in our Python program, we don't need to write pandas.readcsv. We can just write pd.readcsv. Basically, it's a short form and it helps you a little bit. So it's a simple explanation. So we use this function which is stored in the pandas library called read CSV. So when you pass your file path into this function read CSV, it will read the CSV and store in this variable called Melbourne data. And if you want to get the output of what is stored in Melbourne data, you can just type Melbourne data or print Melbourne data or Melbourne data.head. You will get all those kinds of outputs. So we'll go to that right now. And you're again interpreting data description. You all can have a look at it. So what is this 25%, 50%, 75%? All this I can read it. And when we go further, we will also come across something called IQR, that is interquartile range, which has this again 25, 50, 75%, and how you do all of that. So we'll come to that later. So let's start exercise right now. In the bottom right, you all will see that there is this exercise we have right here. I'll click on start exercise. And we come right here. Okay, so first thing is we have this exercise will test your ability to read the data file and understand statistics about the data. And then we will apply the techniques to filter data, build a machine learning model, and iteratively improve your model. The course examples use data from Melbourne. All of this, you can just read it, not a problem. So we'll come to the exercises. So first thing, run the following cell to set up the code. So let's cell, let the resources get allocated. So basically here, if you all can see what is written is session is starting. That means Kaggle is allocating CPU and a storage for me because I'm running this whole data set, this whole machine learning model on their, server. So see right here, if you all see, you have the session, you have the disk space available, 73 GB, CPU available, and RAM available. 30 GB RAM is available. So whatever, all this is given to us. And okay, so so this is just a code block to do the checking part. Kaggle has to check the outputs that are getting. So if you all have any doubts, you all can post it right here. I can see that. And step one, we have is loading data. So we read the Iowa data file into pandas data frame called home data. So first of all, we import pandas data frame, and then again we store this file path into a variable, and we use the pd.read CSV file and pass the file path into the read CSV function. You will get it. It will be the whole data frame will be stored in home data. Now to get the output of home data, so what will I do? I'll say print home data. I'll get this output. Cool. Now what's happening right here? I'm getting such kind of output. It does not look very appealing, right? So I'll just try and say, okay, so this is how it's printing, not a problem. Otherwise, usually if you run it on a Jupyter notebooks, you will get a better output. And okay, so basically what we did is we stored the CSV, the data frame in our variable called home data. And here what I did is I printed the home data. So what happens when I do a print home data is, I'll just show you the difference. It prints all the values in the home data. So if you see the first we have is the ID, MSS subclass, MS zoning, and all of these different things we have right here. In that, we have the first five values printed and the last five values printed. So basically, if you print the whole variable home data, you will get the first five values and the last five values. It will not be able to print all the 14,060 values or samples because it's too long. It does not have that much memory to print all of it. So that's how it works. And if I do a home data dot head, what's going to happen is it will print only the first five values in the variable. So if you see, it's printed just the first five values of all the different features that we have right here. And same way, what is the opposite of head? It's tail. So if you print home data dot tail, it will print the last five values. So see, home data dot tail is right here, and it prints the last five values of the whole data set right here, data frame also. Okay, so this is just to check if your file has been read carefully, if your file has been read correctly, and if it is working correctly. Okay, and here we have this function called step1.check. This is given by Kaggle itself, and this is for them to check whether what output we are getting, if it is correct or not. If it is correct, we'll get this output right here correct. Okay. And once again, if you are facing a problem while solving this, there is a function given here, step1 dot hint and step1 dot solution. What you'll need to do, just run this. So when you run it, what's going to happen? You will get a small hint. Okay. Use the pd.readcsv function as the hint. And if you are not satisfied with the hint, you can directly go for the solution, which will be right here. So this directly gives you the code line. You can copy and paste it here, and you can use it. Okay. So this is already solved. For people who have not solved, it's for them. You can do it this way. Moving further, if you want to review your data, you can use this home data.describe. It will give nicely in terms of rows and columns. So this is how it gives. So here, if you see, there are different kinds of outputs that we're getting. We're getting the count, mean, standard deviation, minimum, maximum, 25%, 50%, 75%. So basically, from each feature, these are the different values that you're getting. So from the ID feature, the minimum value you're getting is 1, and the maximum value that you're getting is 1460. What is the 75% value that you're getting is 1095, 50th percent, 25th percent, all of these are given. You have the mean, you have the count also, and you have the standard deviation also given right here. So all of this comes through home.data. Sorry, home data.describe, my bad. You have the describe function right here. That will give you all of this. Moving further, we are trying to manipulate our data a little more. So what we'll do is we're importing different libraries that we have right here. Okay. So I hope everyone is following. If not, please let me know. कुछ doubt अगर है या फिर and Prathamesh, okay, I'll just read out your doubt. Course 1 and got stuck at 5 out of 7. I don't know why message was showing. Make sure you have written code with random state equal to 1. Although I got the fundamentals in the first course clear. Oh yeah, Prathamesh, I understood this error. We'll come to that, okay? Since this will take a very long time and we have 2 courses to complete, I am going a little fast. I hope you all will be able to catch up. If I'm going too fast, please let me know. I'll try and go a little bit more slower. So moving further, we'll import the different libraries that we have right here. Now once again, we have another library called NumPy, and we're importing it as NP. Okay, actually all these codes are given by Kaggle itself. We just need to run this code and tweak a little bit to get the output they have asked us to get. Most of the code is given by them. So import time, date time, it's all given. And so date time, so when you have the time and date time will give you the current date and time, the previous date and time, whatever you ask it, it will give you. So when you have the date time dot now, it will give you the current year, month, date, and time of right now itself. So that's what this function does. So it will store all these values in the current date time variable, and you will extract the date from the current date time dot date. You will extract the year from date dot strf time, and you'll give percentage capital Y. So when you give percentage capital Y, what's going to happen is it will extract the year from the date. If you all want, I'll just show you. See, right now we have from the current date time. I'll show you the current date time also. See, like I mentioned, the current date time will give you the year, day, month, date, and the time also. It will give you the whole thing. Now from this thing, we want only the current year. So how can you extract that? First, you will extract the date. After extracting the date, you will get the output right here, 230330. That is right here from the date. Now from the date, you need to extract the year. And how will you do that? You will call the date variable right here, and you will give it a function called strf time and pass a parameter as percentage y. So percentage y will give you the year, and if you say percentage m, it will give you the month. I'll just show you all. Okay, I think it's small m. So see, so if you pass the small m, you will get the current month from this date. Okay, and no doubts. If you pass small m, you will get the month, and again if you pass d, you will get the date. So you will get the output as 30. You get it? So this is the different functions that we have in Python, and you can use it to extract whatever you'll need to. So right here you have print current year as the year. Okay. Now what we need is you have to derive some insights from them. So how are you going to do that? They've asked us a question: what is the average lot size rounded to the nearest integer? So what is the lot size? So we have basically a feature called a lot size. We'll just have a look at that. So we have the lot area. Now lot area and lot size are a little bit similar. They are the same thing, I mean to say. So if you'll just look at it, we need to get the mean of the lot area. So the value right here is 10516. But you cannot extract this specific value that, give me the mean of lot area. It doesn't work that way. You have to follow specific syntax. So we'll just look at it how it works. So what you need to do, you need to call the function, you need to call the library called numpy, and in that you have a function called average. Now within this average, how will you tell that give me the what you say lot area ka average? So you will call your first data frame. I hope you know what home data is all about. Home data right here is we have created our data frame. Okay, this is our home data. We've stored all our values in home data, created our data frame. Okay, and in this data frame we have passed our parameter of lot area. Hence it will go in the home data frame like this in our lot area, and it will scan through whole lot area. It will add all the numbers divided by the total number of values samples and give you the average. So that's what numpy.average function does. Okay, and you store it in average lot size, then you're converting this average lot size into int. Okay, and you're printing the lot size. So that's how it works. And so as of today, how old is the newest home? Now the formula for calculating this is current year minus the date in which it was built. So basically this is why we were extracting the current year in the previous thing. I hope you all understood. So the date in which it was built, the house. Okay, so first what you need to do is you need to get the, okay, so see, you have the value years sold right here. So in the years sold, I'll just show you just a second. Okay, so see, so in this data frame, you have the feature called years sold. In that, you have such values 2008, 2007, 2008, 6, 7, whatever, 2010, everything. Now, you want to calculate that which is the latest home which is sold in this whole data that we have collected. How will you do that? You have to access first this data frame ka feature called years sold. And once you access that, you need to get the maximum value that is present in this. So you will just need a function called max, which is inbuilt in Python. In that you will pass the feature or the parameter of home data, and in that you will pass year sold. So it will go to the home data frame. In that it will access the year sold, and within that you will find the max and store it in the newest home. And then you will calculate the newest home age is the current year that you extracted minus the newest home. So current year is 2023, and newest home will be, I think, let's just check what is the area. Okay, wait. See, the newest home age was 2010. So 2023 minus 2010 will be 13 years. Okay, so that is basically the value for the newest home, and we are getting this error. Is okay. Let's just. So what is this error? 1057. Okay. So I think basically you need to round this, and when you round this, you will get the value of 10517, the average value. Okay. And using data read from home data.describe. Okay, so basically what they have done is they've accessed from this describe function, they have accessed the lot area ka mean, which is 1056.8282, and got rounded it off. So you get it 10567, whatever. So that's the output you get. So not a problem, you all can do that also. And moving on, newest home age. Okay, we don't need time. just show that. If you all look at this right here, we have calculated the newest home age as the current year minus the newest home, and we've printed it right here, which comes to 13. And in the solution also, if you see the newest home age is equal to 13, so that part is correct. And we've got it 10517. All we need to do is round this up, and when you round this up, you will get the correct answer. Let me see if I'm able to do it. Okay. Okay, yeah. So we've got this right here. So yes, so as you all saw, what we did is we calculated the average of this and we rounded off that to the nearest integer that we found, which is 105.7, 10517, and we got the correct answer, which matches with this right here. And now think about the data. So the newest house in your data isn't that new. A few potential explanations for this is the data. They haven't built new houses when this data was collected, and the data was collected a long time ago. Hence, the houses built after the data publication won't show. So that's the way you can understand why is the latest house in our data set so old. That means 13 years old. So the data set is very old, and it won't be as useful if you want to implement it for current use cases. So moving further, we'll go to start building your machine learning model. In the bottom right, we have right here. I hope you all can see it. We have the start tutorial. So we'll go to that. And in this cell, I directly entered the values by looking at the table. Is it okay? Prathamesh, I didn't exactly understand how to do that. You have to calculate the mean, sorry, the average. You cannot enter the values directly. So that is the problem that we need to solve. That we have to calculate the average and not just enter the values. I hope you saw the way I did it. So maybe it's just the same. You can do it. That lot area and your okay. You don't need to enter the values. You have to calculate them from the data set that was given. Okay, there it's was printed. Okay. Prathamesh, I hope you saw the way I solved it. That is the correct way that you need to solve, not just enter the values. So you can do that. So you can solve it once again and calculate the values, but don't just enter it. Okay, that is not the way, because you need to understand right how you code. You need to extract the data, perform manipulation. Otherwise, since they gave you the answers, you were able to enter it. What if they had not given you the answers? You would have to calculate that, right? So that's what you need to do. Moving further, so we have the your first machine learning model right here, and here we have selecting data for modeling. Your dataset had too many variables to wrap your head around or even to print out nicely. How can you pare down this overwhelming amount of data to something you can understand? So we'll start by picking a few variables using our intuition. Later courses will show you the statistical techniques to automatically prioritize variables. Okay, so we have this. Of course, so basically what we have right here is we've tried to get all the number of columns that we have and which all columns we have. So we have all these types of columns in our Melbourne housing data set. And the Melbourne data has some missing values, some houses for which the variables weren't recorded. We'll learn to handle the missing values in the later tutorial. Your Iowa data doesn't have any missing values in the column you use. So we will take the simplest option for now and drop houses from our data. Don't worry about this for now. The code is you drop NA access 0. Okay. So what happens is your data set actually is not always clean. It has a lot of missing values, dirty values, unnecessary values. So you need to either fill the values if they are missing, or you need to drop the samples which don't contain those values. And the function for that used is drop NA. Now when you say drop NA, drop is the word and NA stands for not a number. That means the values which are null or not numbers or which have unnecessary characters in them, you can drop those samples. So basically, that's what it does. And there are many ways to select a subset of your data. Pandas covers more in depth. Dot notation we will use to select the prediction targets, selecting a column list, and all of this. Okay. And here it is getting a little more complex, so I'll have to explain more nicely. So, guys, I hope you'll understand when you're creating a machine learning model, you'll have to create two variables called x and y. Y will be the predicting variable, and x will be all the features that the model will train on. Okay. Now, rooms, bathroom, land size, latitude, and longitude are the features that the machine learning model is going to train on, and it will predict these values, the y variable. Okay. Now, Melbourne features, we are storing it in a variable called x. Okay. And we'll say x dot describe. When you say x dot describe, these are all the features that we just specified, and these are all the different values that we are getting in those, this. And again, like I said the last time, when you do the x dot head, you will get the first five values, and that's exactly what you're getting right here. Okay. And okay, so now let's go to building your model. So we have another library called sklearn, and from sklearn we're importing the decision tree regressor. Okay, so we basically define our model. That means we call the decision tree regressor model, and we specify the random state equal to 1, and we store it in our Melbourne model value, sorry, variable, and we call the fit function. And the fit function is basically what does the training. So we say the model training, right? That our model needs to train. We call a algorithmic function. So this is what it does. So this is where we call the algorithmic function. We're initializing the algorithm, passing the variable of random state equal to 1, and storing in a variable called Melbourne model. And when we are calling the fit function, we are passing the x and y values into it. X is the training values and y is the predicting values. So for all the values of x, the model will learn that y is the output. So that's how it learns, and the model will be able to learn that way. So we'll go ahead, and the way it does predictions is print x dot head and print Melbourne model dot predict x dot head. So basically, these are the input that we're providing. Okay, so this is all the input that we're providing to our model: rooms, bathroom, land size, latitude, longitude, all of these different features, and the predictions for these are all of these different values. Predict Melbourne model dot predict x dot head. So here there are 1, 2, 3, 4, 5 values, samples that we're providing to our model, and these are 1, 2, 3, 4, 5 predictions the model is giving. Okay, so for the first house, the model is predicting this price of the house in dollars, and for the second house, it's predicting this value of the house in dollars. That's how. So moving further, we'll start our exercise right here, and here. I hope there are no more doubts, right? If anyone has any doubts, so I can ask in the chat box. Okay, I've just started the session, and here we'll again perform whatever they specified right there, like before what we saw. We'll just go through all of that. And again, we are performing the read CSV and storing it to home data. And these are the Kaggle pre-built given function that we have to import and run. Okay, so we basically don't need these while running or building a machine learning models. This is just given for your Kaggle for this course. So we specify the prediction target. Select the target variable which corresponds to the sales price. Save this to a new variable called y. You'll need to print a list of columns to find the name of the column you need. So print the list of the columns in a dataset and find the name of the prediction target. So how do you do that is you call the house home data, which is a data frame dot columns. So when you call this, it will print all the list of features that are present in your dataset. Now there are so many features. It's too hard for ourselves to understand which feature might be important, which feature might not be important, and it's a big headache for us. So they made it easier for us, and given us a set of 3 4 features to use for a training a model. So let's just look at it. So first of all, what we do is we are splitting a data set into x and y, where x is the the features which the model will learn from, and y is the target feature. So when you feed your model all the features of lot area, your built, and all of these different features, then the model will understand for the values of this, y will be the price of the house. So if I just give you a small understanding, if I just look at how this works is that, so we have right here is all these list of features and all these list of samples. So what's going to happen is the model will learn that all of these features, imagine for the first sample, that is the zeroth sample, all of these values that are present right here till the sale condition. Okay, the model will learn for all of these values the price of the house is 20,000 and $8,500 or whatever. So that's how it works. So you're splitting this data set into the X variables and the Y feature. So all of these, features, sale condition till the first feature, will be the features that the model will train on, and the model will then learn that for all of these features, these are the list of values which are actually the price of the house. So that's how it works. So what we are doing is we are storing the last feature, that is a sales price feature, in a variable called y. Okay, so that's how what we are doing. And then what we do is we are creating x. So for creating x, they have specified that these are the list of features that we use for creating x. And what we do is we create a array called feature names and pass these parameters in them, or the names of the features: lot area, your build, first FLRSF and second FLRSF, full bath, all these different features. And then we are storing all these different features in our X variable. And then when we do the step to dot check, it's correct. So here what you've done is you've defined the X variable and the Y variable. So if I just, show you all how it looks, is that this is how it looks. So basically all these other features that the model will train on, and these are all the samples. So there are 15,000, no, 14,050, samples given that the model will train on. And from all of these different features that the model had to learn from before, so many different features, we've reduced it to barely 6, 7 features. So that's, we are making it easy for the model. And then we'll just review our data. That means we'll print the x.describe and y.head. So all of these are the features that we have right here, and this is the y feature that we have right here. Now we'll specify and fit the model. So how we will do that is, like you saw before, like I explained, we have the decision tree regressor, and we are initializing the algorithm by passing the random state as 1. Now I'll just talk about the random state in short. Random state, basically, it could be any integer value from 1 to infinity. That's not a problem in that. So basically, what this does is it just helps your model, the decision tree regressor, to select the different features, the samples from your model. So that's how it works. So we'll come to this later also when we are taking offline sessions. I'll cover this in more depth. Right now, it's a bit hard to go in very deeply because there are other lot of things that we need to cover, and only then we'll come to this. That will make you understand more easily. And then we'll do the, so we basically defined our the model in a variable called Iowa model. Now we'll call that model, and we'll perform the fit function. Like I mentioned, fit is where we perform the training of the model. Okay, so Iowa model dot fit is the training, and you're passing the x and y variables in them, and then you will do the check, and that will be correct. Now we'll perform the make predictions. So how this works is that you will create a variable called predictions, and you will do the Iowa model dot predict x. Now x will be all the different samples that the model has learned from, and it will predict those and store in a what do you say, variable called predictions. And we'll print the predictions, and we'll print y, and we'll see how it works. So basically, if you see, the first prediction, or the value of prediction for x of 0 is 208500, and the actual value present in the dataset is 208500. That means it has predicted correctly. The model is predicting correctly. And then we have 181500, 181500, 223500, 223500. So all of these are the different, predictions. These are the predictions the model has made, and these are the actual values present in our data set. So that's how it works. So the first value is right here, second value is right here, third value is right here. So if you just compare and see, all of these values are absolutely correct that the model has predicted. So then we can say that our model is very strong or robust. That means it's predicting very correctly. And again, did I run this? Yeah. So if you run this again, you get the output as correct only. You all can see. I hope I've explained it pretty decently for you all to understand. If you all have any doubts or questions, please let me know in the chat box. Once again, I'm telling. And yes, so use the head method to compare the top few predictions to the actual home values for those safe homes. Anything surprising? That's what they've asked us to do earlier, but that's exactly what we've done right here. Okay, and we'll go now. We've completed this also. We've built a first machine learning model, trained and tested it also. We've seen how the predictions are, and we'll go to the next part is the model validation. Bottom right, I'm clicking on start tutorial. As you all can see, we'll move ahead. Okay. Now again, this model valuation validation, you have a lot of theory given here, and you all can of course read through it. Now, an important keyword that you have right here is mean absolute error, also known as MAE. For those who attended the offline session that we had conducted, I had mentioned, I and Saurabh, both of us had mentioned there also that for machine learning algorithms, we have something called performance metrics. Now, in those performance metrics as well, we have the mean absolute error, present the MAE. Then we have the mean squared error also present the MSE, and there are two three other kinds of performance metrics as well. So for this, they have used the mean absolute error. So we'll stick to that and we'll see how it actually works. Let's just see how it actually works is. So if a house costs 150,000 and you predicted it would cost 100,000, so the error is 50,000. I hope you'll understand that there are two things that we're doing right here. First of all, we are predicting what we are making the model predict the values, and then we are comparing the values which are actually already present in our data set. So 150,000 is what the model predicted, but the actual cost of the house was 100,000. So the error that we have right here is 50,000. Now, what we need to do is we need to minimize this error. So to minimize this error, there are various other approaches that we have. We'll come to that later. So now, how do we know that a model is predicting good? When we have these kind of validation techniques, like mean absolute error or mean squared error, we know that the model is predicting good or bad. I hope you'll understand. When the model has an error of such a big value, that means it is not predicting very well. If the cost of the house is 150,000, and maybe the model predicted that the cost of the house is 148,000 or 149,000 or 153,000, it's pretty understandable that the model is doing decently, if not extremely accurate. So, mean absolute error is one way of determining how good the model is doing, and this is all the steps that we performed before only. We import, load the data set, specify the x features, the x and y variables, import the decision tree, perform the training using the fit function, all of that. And now from sklearn.metrics we import mean absolute error, and we call the model Melbourne model dot predict x, and then we are comparing the values of the actual value in a data set and the predicted values, and we get the mean absolute error as 434.71, etc., etc. Now that's how it works. So mean absolute error is what we calculated as 434. Now the minimum this value is, the better and robust the model is. That's the ideology behind it. And the problem with in samples scores, so you can of course read it once and see what this is all about. Coming down, we have another this. Okay, so right here we have the train x, train y, validation x, validation y, and this is very important. This is what you'll need to understand, and I'll go through it. You'll understand it quickly also. And if you're not, please let me know in the chat box. And okay, no problem. Wow. So we'll start with the exercise, and during the exercise, I'll explain how things are being done. Again, we have the recap. So in the recap, I don't think I need to go through all of it. We just train our model, define the x and y, then we perform the fit function where we train our model, and then we have the first in sample predictions where we're printing the first five values, predicting the first five values, and then we are printing the actual first five values. So we'll compare and check. So as you can see, these are the first five predictions that we have at the top right here, and these are the first five actual values that are present in our data set. So as you can see, every single value matches. That means the predictions are extremely correct, and our model is highly robust. That's what basically this tells us. Now we come to an important topic called splitting your data. Okay. Now, if you'll remember, I just said some time back that we were splitting our data into x and y variables, right? Is exactly what we've done right here. But x and y variables, that was for our model training to help our model understand that what is the predicting feature and what are the other dependent features. Now, if you ask me for the x and y, I'll try and give you a simple explanation. Now, uh, x that we have right here, the x variable, which contains all of these different features. Now, all of these different features are independent features. That means the lot area is not dependent on any other feature. The year built of the house is not dependent on any other feature. But if you see the y value, the y variable, it is a dependent feature. That means if the lot area from the x variable or if the year built from the x variable changes, then the price of the house will change. Now, what does that mean? That the y variable is a dependent feature and it is dependent on x. But our x feature, x variable that we have right here, it's an independent feature. That means an x is not dependent on anything, it's completely independent. Okay, I hope you understand. And now we have the split your data. Now, split your data, what we do is that we have a data set consisting of maybe, just imagine we have a data set consisting of 10,000 values, 10,000 samples. Okay, now we will split a data set into two parts. You will split it into a training part and a testing part. Training part is the amount of samples where our model will train on, and testing part is the amount of samples which our model has not even seen, that our model has not even seen. Okay, so since the model has not been seen, it will not know about that data at all, and that data is completely new for the model. And then when the model predicts on those values it has never learnt on or it has never seen, then we can actually understand of how good or robust our model is, right? If our model is already learned on certain values and it is predicting on those values, then we will get like this kind of output. We'll get exactly matching values. That means that our model is 100% accurate because it is predicting from those values which it has already learned on. But actually, if you have to test the model nicely, you have to test it on values that the model has not learned on or not even seen. So that is why you perform the training and testing training and testing splitting. That's why you split your data. So we import the train test split from sklearn, and this is actually a you know correct way to form your train test split. So even if you're performing your own machine learning codes or creating your own models, please use this same method. So right here we have the train test split function that we call, and we create four variables: train x, validation x, train y, validation y. Now validation x and validation y is same as test x and test y. Okay, so the output of train test split is basically four different values. Okay, one value will some set of values will go in train x, some set of values will go in validation x, some set of values will go in train y, and some set of values will go in validation y. Now, in this train test split function, we perform certain parameters, and these parameters are x, y, and random state. Now, random state that we have right here basically means that which you know uh, which part of your dataset that this train test split needs to take. So random state one will say that the train test split can consider maybe the first 80% of your dataset into the training part and the remaining 20% of your dataset into the testing part, or maybe a random state of maybe 10, 20, 30. Random state could be any integer from 1 to infinity. Okay, so if I change the random state into 8, it won't matter at all. Okay, we didn't run this at all. We get an error. So actually what I'm saying is that the random state can have any value, integer value, and we have the train test split right here passing the x and y. like I said, we'll get an error because we have not executed this first code block. So let's just execute that. Okay, good. Okay. Okay, so basically what error that we're getting here is the training data has different rows than expected. Why is that? It's because we've changed the value of random state from 0 to 8. If you just leave it at 0, what was that? 1. Okay, so if you just leave it at 1, then you'll get the correct output because Kaggle was expecting certain set of rows, and if you change the random state, those rows change. It doesn't affect your code, but Kaggle needed those specific rows, hence it gave the wrong output. And Prathamesh, was this the place where you were getting an error, or was it somewhere else? If you could just let me know in the chat box. Okay, so till the time Prathamesh lets us know, we'll move a little ahead. And moving further, we'll specify and fit our model. So how that is done is basically what we will do is we've imported our decision tree regressor model, and we specified our random state as 1, which matches with a random state as 1 right here. Okay, and we'll store it in our variable, and we'll perform the fit function and pass the values of train x and train y. Okay, so train x will contain the features that the model has to learn from, and train y will contain the features that the model has to predict on. Okay, so this is where the sales price or the price of the house is present in the train y, and the train x contains all of the other features present that the model has to learn from. And we'll run this and we'll see what output do we get. Basically, what output we get is this. So, okay, let's see. Okay, no problem. Okay, so the output that we get right here is these are the predictions of the model, and these are the actual values present in our data set. So if you see, most of the values are similar right here, and none of the values are different. That means a model has learned very well on a data set, and it is able to predict also very well. So that's what this output tells us. That's how it works. Now make predictions with validation data. Okay, so this basically was predicting on our trainings itself. This is our predictions, and this is our data set contained values. That means they will be same. Now we will check for the values that the model has not even seen. What predictions does it make on those? If you just look at that, we'll come down here. Okay, right here. So we've performed the predictions on validation X. Now this values the model has not even seen or learned on. We'll store it in a variable called val predictions, and we'll leave it right here. Coming down, we will check if the val predictions values and the val y values are matching, or up to what extent are they matching. So if you just look at it, we have printed the validation predictions value. Now val predictions are the ones which we predicted right here from val x, and val y is where the actual values of a data set are present. So if you just look at it, first prediction is 118,6500, but the actual value is 23,1500. So if you see right here, how these values are so different, how the predictions are so different than the actual values present in a data set. So this is what happens when you train a model, and this is how you evaluate your model. You evaluate a model based on the values the model has never learned or seen on. That's basically how you evaluate a model. If you see right here, the last prediction is 26,000, what do you say, whatever, 26, 2,000, and the value we have right here is 25, 27, 5,000. So it's pretty close to each other, but yet not same. The model can always be improved more, and we have the different techniques, hyperparameter tuning, and all of those different things. We'll look into that later. So basically, that's how it works. Okay. Now coming to step 4, calculate the mean absolute error in the validation data. Like how it was mentioned before, first of all, you have to import the mean absolute error, and when you import that, you call the mean absolute error function and pass the val y and the val predictions, you know, variables as the parameters. Now val y is where the actual values are present, and val predictions are where the predictions are stored. Okay, now I'll just run this. We get the correct output. And if I just, okay, so the main absolute error of validation set, see it's 29,625. It's a very, very large number. That means the model is extremely poor in predicting. Our model's predictions are very bad. Hence, we have such a mean absolute error value, such a big value for mean absolute error. But for a good model, for a very fit model, a robust model, the mean absolute error would be close to maybe 1, 2, 3, 4, or as small as possible. That's how it basically means. Okay. So again, we have right here. I hope you have understood how you do the validation part, why you do the train test split, why you split a dataset into X and Y variables. I hope you've understood that. If not, we'll come to that later again. For now, we'll move on to underfitting and overfitting section. Okay. If you all have any doubts, once again, you can let me know. Okay. Now, underfitting and overfitting, we have a lot of theory right here. So basically, I will give a small explanation of what underfitting and overfitting is all about. Now, when you saw your model, what predictions it made, what kind of accuracy it had, what does the mean absolute error we saw what it had. So we have actually three different concepts for evaluation in machine learning, which are an underfit model, an optimal fit model, and an overfit model. Now it's a little difficult to explain on a short span of time and this way, but I'll try. So basically, an underfit model basically means is that the model has learned on a training dataset, but it is performing extremely poor on the testing dataset. That's basically what underfit means. That means the model has not been able to learn anything from your training dataset. And even if you provide your training data set for prediction to the model, it will perform poorly on that as well. That is basically an underfit model. That means it's pathetic. It's bad at predicting the values it has learned from and bad at predicting the values it has not learned from both. Moving on, we have overfitting or an overfit model. So an overfit model means that the model has learned on the training data set and the model has to predict on the validation data set. Now, the model is predicting on the validation dataset. The predictions are very poor, and accuracy is very poor here as well, just as the underfitting model. But if if you pass the values that the model has learned from for prediction, the model will perform very well there. That is basically what an overfit model is. So overfitting basically means कि आपका मॉडल ने रट्टा मारा है ट्रेनिंग डेटा सेट को, तो ट्रेनिंग डेटा सेट से कुछ भी पूछेंगे तो सब करेक्ट आंसर देगा, लेकिन वैलिडेशन डेटा सेट से कुछ पूछेंगे तो सब गलत आंसर देगा. एंड अंडरफिट मॉडल वो होता है जो ट्रेनिंग डेटा सेट से सीख चुका है, लेकिन वो भी इतना घटिया तरह से सीखा है कि ट्रेनिंग डेटा सेट से भी कुछ पूछा तो नहीं आएगा, वैलिडेशन डेटा सेट से भी पूछा तो वो भी नहीं आएगा. And then moving on, we come to the third part, which is an optimal fit. Optimal fit basically means basically means कि एक underfitting and overfitting का बीच में आता है वो. That the model has learned on a training data set and it is able to predict pretty decently on a validation data set as well. So यहाँ पे मॉडल ने रट्टा नहीं मारा है ट्रेनिंग डेटा सेट को, अच्छे से सीखा है, समझ समझ के सीखा है सब कुछ, और फिर वैलिडेशन डेटा सेट पे भी प्रिडिक्शंस अच्छे से कर पा रहा है. लेकिन अगर रट्टा मारा होता तो वैलिडेशन डेटा सेट पे अच्छे से प्रिडिक्शन नहीं कर पाता. दैट्स व्हाट ओवरफिटिंग इज ऑल अबाउट. So I hope you'll understand what that means. And okay, so if you have, we have a visualization right here. So of mean absolute error. So the red line that we have right here is validation, and the blue line that we have right here is training. And here we have is the tree depth. And underfitting and overfitting में क्या होता है? We'll just have a look at that. So underfitting में basically जो ये होता है validation में, जो ट्रेनिंग जब कर रहा है मॉडल, so it will validation मतलब values पूरा नीचे जा रहा है underfitting में. It is not able to what do you say perform good at all. इतना बुरी तरह से perform कर रहा है. लेकिन overfitting में वैल्यूज का प्रिडिक्शंस ऊपर जा रहा है वैलिडेशन में, मतलब इट्स एबल टू प्रिडिक्ट प्रीटी डिसेंटली. एंड अंडर फिटिंग में फॉर द ट्रेनिंग डेटा सेट द वैल्यू प्रिडिक्शंस आर अगेन गोइंग डाउन, एंड ओवर फिटिंग में तो पूरी की पूरी नीचे चला जा रहा है. बेसिकली आइडिया ऐसा है. And I'll actually upload one YouTube video that I myself have made on underfitting and overfitting. You will have an understanding what it actually is after our session. मैं ग्रुप पे अपलोड कर दूंगा तो वो देख लेना एक बार. I hope you'll understand through that. So here there are a few alternatives for controlling the tree depth. Many allow some roots through the tree to have greater depth than other roots, whatever. So the more leaves we allow the model to make, the more we move from underfitting area in the above graph to the overfitting area. So we can use a utility function to help compare the MAE scores from different values from max leaf nodes. So here again, for the coding part, we are importing the mean absolute error, importing the decision tree, and we are creating a function called get mean absolute error. So for this function called get mean absolute error, we are passing the different variables, parameters like max number of leaf nodes that is allowed, the train x, validation x, train y, and validation y. And then you're calling, initializing your algorithm, decision tree algorithm, and then you're performing the training, and then you're performing the predictions as well. And then you're calling the mean absolute error, and you're checking the predictions that the model has made. So the data is loaded into the trainx, trainY, and all we've understood all of that. So basically, this is what we've already done before, splitting a dataset into x and y, and then splitting a dataset again into trainx, trainy, validation x, validation y. And we can use the for loop to compare the accuracy of models built with different values for max leaf nodes. So for max leaf nodes in 550, 500, and 5000, so what we're trying to do right here is we are trying to compare different models, okay, with different number of leaf nodes. So the more number of leaf nodes we have, the better it will be for the model. So for example, if we have only 5 leaf nodes, the model will not be able to understand a lot. But if you have a 50 leaf nodes, the model will be able to learn a lot. And if you have 500 leaf nodes, the model will be able to again learn a lot. But if you have 5000 leaf nodes, the model will ratta, like training data set को पूरा रट्टा ही मार देगा. So अगर बहुत कम values है leaf nodes के लिए, it will perform underfitting. बहुत ज़्यादा values है, it will perform overfitting. तो हमेशा हमको एक balance ढूंढना पड़ता है बीच में for a middle value. If you just look at these outputs that are there right here, so for max leaf nodes of 5, you have an MAE of 34,000, which is a very big number. For max leaf nodes of 50, you have an MAE of 25,000. Okay, the mean absolute error has decreased a lot, and that is because the max number of leaf nodes have been increased. And again, if you're increasing the max number of leaf nodes to 500, your mean absolute error is reducing to only 24,000, pretty much small, because now the model is kind of generalizing a lot. ज़्यादा कुछ नहीं सीख पा रहा, इतना ही सीख सीख सकता है मॉडल. दैट कुड बी द ओनली पॉसिबिलिटी. एंड अगेन इफ इंक्रीजिंग द लीफ नोड्स टू 5000, 500 हमको कम पड़ा, बोला कि ठीक है 500 पे मॉडल का एब्सोल्यूट एरर सिर्फ इतना आ रहा है, विच इज अ लॉट, वी नीड टू रिड्यूस इट. बोला ठीक है, सो नाउ वील इंक्रीज द नंबर ऑफ लीफ नोड्स, थिंकिंग कि मेरा एब्सोल्यूट एरर और भी कम होगा. लेकिन इफ यू लुक हियर, मेन एब्सोल्यूट एरर तो और भी बढ़ चुका है. एंड व्हाई इज दैट? इट्स बिकॉज हियर इट्स परफॉर्मिंग ओवरफिटिंग, and here both these places is performing underfitting. Only here where the leaf nodes is 500, which is a balance between 5 and 5000, it is getting an optimal value of 24,000. So basically that's how it means. So our overfitting is capturing spurious patterns that won't recur in the future, leading to less accurate predictions, or underfitting, which fails to capture relevant patterns, again leading to less accurate predictions. So we saw what overfitting and underfitting is. Moving on, we'll just go to the exercise. And Prathamesh, your error which you're facing right here, I hope that's cleared, or you could just let me know if it's not. Random state का जो error आ रहा था आपको, if that's cleared, let me know. If not, let me know. We'll work on that. Or you can ping me personally also. It's clear? Okay, great. No problem. Cool. So first of all, we have as a recap that we've already done. We create a मतलब path एक variable में store करते हैं, call everything, create x y variables, split a data set into train x, train y, random state as one, do everything, specify model, perform training. After training, you perform your predictions. After predictions, you're checking your validation values as well. Okay, using the mean absolute error check करते हैं. So पहले predictions करते हैं, predictions के बाद mean absolute error check करते हैं, and वहाँ पे we check this. Okay, so mean absolute error of validation set we are getting is 29,000, which is a big number, right? So moving on, we are creating a function called get MAE, and using this function, we are passing a you know parameter called max number of leaf nodes. So this is where we'll check what kind of different leaf nodes will get us different MAE scores. So we'll just run this. We'll create this function. And now you will say candidate max leaf nodes are 5, 25, 50, 100, 250, 500. You can add any number of leaf nodes you want to any integer value. It does not need to be a multiple of 5. Okay. Then what we are doing is we are saying scores is equal to leaf size get MAE. We are calling the function, passing the leaf size. Okay. So basically what this line that you'll see right here. Okay. This is a list comprehension that is performed right here. Okay, that is another important concept which is used in Python. It's called a list comprehension. You can Google and learn from it later. For now, I'll just give an explanation of what this line does is. So हम जब for loop बनाते हैं, for loop में हम एक conditions डालते हैं कि loop में जाओ और ये perform करो. So in this line, what it does is that it performs the whole for loop in one line itself. That's basically the idea. So what we get right here is for leaf size and candidate max leaf nodes, where candidate max leaf nodes is this, okay, this array. So basically we are looping in this array and our iterator is leaf size. Okay. And then in this for loop, we are calling the function get MAE. Okay. And we are passing the variable leaf size and train x, train y, validation x, validation y, and all of that. And we are printing the leaf size, which is the most optimal. That's what we are doing. And best tree size will be minimum scores, where you do key is equal to scores dot get. This is the scores. If we just print what the value of scores is, see, this is the value of scores that we have right here. For 5 you have 35,000, for 25 you have 29,000, for 50 you have 27,000, for 100 you have 27,282, where for 50 you have 27,405, and for 250, max number of leaf nodes, you get the value of 27,893, and for 500 leaf nodes you get the value of 29,454. Okay, so I hope you understand. When you have very less number of leaf nodes, you get a large error, and when you keep increasing the leaf nodes, the error keeps decreasing, where for 100 leaf nodes you get the most optimal score of 27,282. When you keep increasing your leaf nodes to 250, your mean absolute error also keeps increasing. Same for 500. At 500 again, it has increased more. So that's what is we are doing right here. Okay. And coming down, step 2 is we do the fit model using all data. Now you know the best tree size. If you're going to deploy this model in practice, you would make it even more accurate by using all the data and keeping that tree size. That is, you don't need to hold out the validation data now that you've made all your modeling decisions. So I hope that line was clear. Now, since you've understood which value would be best for your decision tree, you won't need to perform the validation dataset split that we had done earlier. Okay. And this error is not filled yet. Call fit with appropriate arguments before calling using this estimator. Okay, sorry, my bad. We have this fit function right here. So earlier what we had done, we had actually split our dataset into XY, and after splitting into XY, we split it into train X, train Y, validation X, validation Y. So instead of doing the validation X, validation Y, we directly give all of our whole dataset into the final model dot fit. And again, see, we have the solution also right here. So basically that's what we've done, final model dot fit. Okay, I hope you all understood this as well, the decision tree regressor. If you all have any doubt, please let me know. Okay, should I try it again on model? Okay, Prathamesh, sure, no problem. Again, if you all have any doubt, you can let me know. Moving further, we come to the random forests. So random forest is another machine learning algorithm that we have. And again, you have an introduction right here of what random forest is all about and what you need to do in random forests. All of that is given right here. So we've already seen the code to load the data a few times. At the end of the data loading, we have the following variables: train x, train y, validation x, validation y. And this code we've already performed before. You all know all this: split into x, y, split into train x, train y, and all of those different things. Now we build a random forest model similar to how we built a decision tree in scikit-learn. This time using the random forest regressor instead of decision tree regressor. So this sklearn that you'll see right here, it is also known as the scikit-learn library. Okay. Now while importing, we call it as sklearn itself. So from sklearn ensemble, we import random forest and mean absolute error, and we initialize the model in our forest model variable, and then we perform the fit function, and then we do the prediction on the validation x, and then we perform the mean absolute error. Now, if you'll notice right here, with the mean absolute error using the random forest regressor algorithm, we get as 19,100 and sorry, wait, unit tens, hundreds, thousand, 10,000, lakh. Oh my god. So if you just look at this, we're getting the answer of 1,91,000 of mean absolute error. That means right now, this model is one of the worst model. Sorry, this random forest regressor is one of the worst models to do the predictions. So there is likely room for further improvement, but this is a big improvement over the best decision tree error of, oh my god, okay, my bad. The last time decision tree regressor had errors of 2,50,000 and not 25,000. My bad, I misread it that time. So 2,50,000 से हम improve कर चुके हैं to 1,91,000. So that's basically an improvement that we've done from, decision trees to random forests. Now we'll try using random forests. We'll go to the exercise and see how it is performed. And just for the recap, you already know how this is done. Import the data set, split into XY, split into train X, train Y, import the decision tree regressor that we have right here, and perform the predictions. But here we have to use random forests. So first we'll do the decision trees, then we'll compare with the random forests. Okay. So decision trees, we perform the fit and perform the validation error on MAE, and then we call the decision tree regressor where we are specifying the max number of leaf nodes to 100. Okay, so here we didn't specify anything, but here we are specifying the decision tree max leaf nodes to be 100, and we are training and checking the validation error. So now the output that we get is validation MA when not specifying max leaf nodes is 29,000, but when you specify the max number of leaf nodes to 100, you get 27,000. Now we'll use random forests. Now instead of decision trees, we're going to use random forests. Now we'll initialize the random forest regressor to RF model and set a random state to 1. Let's see what error do we get right here. No error, great. Now we'll perform the fit, that means the training right here for random forest using the train X, train Y. And we'll perform the predictions on validation X and check the mean absolute error that we have right here. Now validation mean absolute error for random forest is 21,760 that we see right here. Okay. And if you see the hint solution, we have all the same things that we have right here. So if you just look at it, so far you have followed specific instructions at each step of the project. This helped learn key ideas and build your first model. But now you know enough to try things on your own. Machine learning competitions are a great way to try your own ideas and learn more as you independently navigate a machine learning project. So now we've completed the whole course one. Next, we'll just have a look at this machine learning computations that we have right here. Okay, so right now, as I mentioned, we have completed the whole course one. We have completed the decision tree and random forest algorithms as well. I hope you all understood what that is all about, what errors that we face, what is overfitting, what is underfitting, what is the splitting of the data set, train X, train Y splitting into X and Y, and all of those different things, and how you perform the validation, and then what is the mean absolute error, why do you need those. I hope you understood all of that. And the last step that you have right here is participate in different competitions that Kaggle hosts. And one of the competitions is whatever you all can, you just go through it and participate in those competitions. So is there any doubt anyone has in course number one? Okay, Ramesh, I hope you have no doubt in course. Okay, great. So Saurabh, I think you can continue with course. Sorry, can
Course number 2 right now.
yeah, it might go late, right?
Yep.
Yeah, and course number two is longer than one, right?
हाँ, I just completed course number 2, जितना भी बाकी था.
Okay, chalega. Then you would like to do course two tomorrow, then is that okay?
हाँ, yeah, fine by me.
Chalega. Prathamesh,
चलेगा.
it's okay if it's done tomorrow as well, right?
Okay.
Okay, yeah. He's also saying we can do it tomorrow. And great. I didn't know everyone started leaving. Was the session that boring?
Nah, it was interesting.
Okay, that's fine. No problem, not at all. Anyways, so we can. So, Prathamesh, I hope you have no doubts. If you have, since you're the only one here, we can clarify it. Yes, Prathamesh, no doubts, right? I hope. Am I getting on the chats? Yes. Okay, so assuming you don't have any doubts, we'll conclude today's session. No doubt right now. Fine, no problem. So we'll conclude today's session and we'll do session number two tomorrow, where we'll do the course number two. And you can join that and attend and see how that works. Okay. So for now, we'll conclude. So thank you, Vedika and Prathamesh, for attending today's session. Thank you, Saurabh, also. I'll stop sharing. Yes. Thank you all for attending. We'll meet tomorrow again for the session number two. And I'll share the week three courses as well right now. You can start with that. Prathamesh, if you're done with week two, and week three, we'll discuss maybe day after tomorrow or something. That's fine. Okay, Saurabh. Okay, Vedika. Okay, Prathamesh. Thank you so much for joining and attending. We'll meet tomorrow again for session number two. Thank you.
Thank you. Bye.
Bye, everyone.